So was the first one 0? Let's write it out. So was the constant 0? Let's see, cosine. Oh no, the constant's so 1. So it was 1 plus 0 plus or minus what? X squared over 2 factorial? I'm just guessing here. I'm waiting for someone to chime in. Is that right? Plus. Sweet. Let's do one more. So plus 0, then plus x to the 6th over 6 factorial. No, is it wrong? 7. Oh, this is 6 and this is 8. And that's minus. Okay, and then we said we wanted to re-index this because we can't see for what values of x this converges unless we have a general term that we can run the ratio test on. So we need a formula like this that gives us these. All right, and that formula is going to be the easiest if we what we call re-index. We want to re-index so that this is, so I said j. So when j equals 1, we want to get 1. When j equals 2, is this right? Is this what we said? So in order to come up with that formula, looking at the ones where higher j values is going to be easier to figure it out. So like down here, it's like, well, there's lots of formulas and give us 1. This just looks like what? X to the j over j factorial. But it's coming up here that we kind of can see. So when j equals 5, we need to get x to the 8th over 8 factorial. When j equals 4, we need to get x to the 6th over 6 factorial. So this goes back to when we started and we did sequences, trying to figure out what the formula is for the jth term of the sequence. Anybody think they got it? So 4 needs to give us, basically what we're looking at here is 4 needs to give us 6, and 5 needs to give us 8, and 3 needs to give us 4. So what do you do to j to get this formula? Five gives 8, 4 gives, let's do one more. What will 6 give? 6 should give? Yeah, 6 would give 10. X to the 10th over 10 factorial. And a pretty brown. And it's going to be minus. Someone thinks they got it. Someone have a hand up over here? He's saying times 2 minus 2. Take 2j minus 2. Does that get us the number we need? So 8 minus 2. 10 minus 2. Looks like it works. 12 minus 2. So this formula would be x to the 2j minus 2 over oh, okay, so what will be a little more convenient here is if we do start this one with 0. I knew something was weird. So that will work, that's fine, but kind of the default is to start now at 0 and only start at 1 or 2 if you have to, like if 0 makes something undefined. So really we should have done this. This will be a little cleaner. Yeah, so this is better. So Here's a choice where we have different options, and we shift to the index. When you use this option, it's just a lot more cleaner and convenient. So all it is x to the 2j over 2j factorial. That's a lot nicer. All right, and that's going to be now starting from j equals 0. Yes, so we have left off the fact that this thing alternates. So we ignored that to start with. So it alternates. So we need it to alternate. So we're going to have -1. It's going to be to the j or the j plus 1? Just to the j. The odd ones are negative. The odd j's give a negative term. The even j's give a positive term. So now I think we got it. Okay. Cool. So we got, what did we just find? We found an infinite polynomial, or a power series, that is reproduces cosine of x. But now the question is, the whole Taylor series, all infinitely many terms, what interval around 0 does it reproduce? So maybe it just gets 0 right at x equals 0. Maybe it gets a finite interval around 0, or maybe it gets all real numbers. It gets this function right, the Taylor series. So that's what we want to find out, and we're going to use the ratio test for that. So let's, yeah, you guys go ahead. So you do the ratio test. What's the goal? For what values of x does that infinite polynomial reproduce the function cosine x perfectly? Okay, so what will the 0th degree polynomial, Maclaurin polynomial, what will that do? The 0th degree Maclaurin polynomial. What's that, Andrew? Yeah, we'll get the function value correct at 0, but that's it, right? So what polynomial is that? The 0th degree. Just 1, right? So what does that look like? Yeah, Nick, what is it? Yeah, it's horizontal line, right? What about the 1st degree Taylor polynomial? That gets what? It gets the function value at 0 and what will that look like? The tangent line. What's that? What's that? It's the same thing. That's why we're skipping, because the 0th degree and the 1st degree is the same function. It just happens that the one that gets just the function value right, it also gets the first derivative right. That's why we got 1 plus 0. And then now the next one, the 2nd degree, will be different. What will the 2nd degree be? It'll give the function value, first derivative, and so what kind of graph will it be? Quadratic, right? It'll be a parabola. Oh no, what happened? 8/9. It's supposed to be x, right? From a previous discussion. All right, let's try that. There it is. So that's the what? That's 1 minus x squared over 2 factorial, which is the quadratic, the parabola that gets what? Function value right, first derivative right, second derivative right. What about the 3rd degree? Same as that. That will also be the 3rd degree, because that will also just happen to get the 3rd derivative correct also. So the quadratic, the parabola, also gets the 3rd derivative right. So then the next one is 4th degree. So isn't this cool, right? So when you do these partial sums, the polynomials do better and better for a further distance away from 0. See how it's reproducing all the way from like -1.5 to 1.5. This 4th degree and 5th degree, right? This also gets the 5th derivative correct. It does a really good job approximating cosine, okay? And then what about the 6th degree? There's the 6th degree Taylor polynomial. And it also gets the 7th derivative correct. Here's the 8th degree Taylor polynomial. And what's going to happen as you keep taking this sequence of partial sums, you keep adding more and more terms. The red graph is just going to keep bending and bending and doing a better job. And you found out that this converges for what? You should have gotten all real numbers when you did the ratio test. And so we see this happening, right? If you keep adding these terms, minus x to the 10th divided by 10 factorial. So just imagine we keep now plus x to the 12th over 12 factorial minus x to the 14th over 14 factorial. You can see what these polynomials are doing. They keep wrapping on cosine x for a larger and larger interval around 0. Let's do here. I'm going to put a bunch more here, as fast as I can. What do you expect to see? Look at that. That is so cool. That's what he said. I heard. All right. So we're going to do the Taylor series for ln of 2x centered at x equals 3. Okay, so I did chain rule times over 2x times 2. What? Should be what? Oh, 3. 1/3. Thank you. This is what you guys got? Some nods, a few nods, okay. So what's happening? What's this coefficient really? The next one will be why am I not simplifying it so that you can see what? What is this? Which factorial is it? Is it n factorial? N minus 1 factorial is what the coefficient is. You see that? It alternates. So is it -1 to the n or n plus 1? So now when it's odd, it's positive, and when it's even, it's negative. So n plus 1 times n factorial times x to the n minus 1, sorry. Yeah. Then to the, like over x to the n. To this. Okay, and then so what do we get here? -6 over 81. I don't know this. 7, 8 something. What is it? 7, what? Thank you. So these are all fine and good, but really this is what all this was about. So getting this general term was all that this was about. So we can start writing it out. But notice when n equals 0, it's not part of the pattern. Do you see that? So that's not going to be part of our general form. ln of 6 just stands alone. It doesn't go in with this pattern. So we're going to have to add that in separately. So what do we do? So ln of 6, 1/3 minus 1/9. Is this right? So we got a choice here. We can make this, so now ln of 6 is not going to be part of our summation when we gather these together and write it as a single term with a summation. ln of 6 won't be with that, right? It's its own thing. So we're just going to have to just keep that separate and add it to our summation notation. So do we want to start with j equals 1? Sure, we'll do that. That's what this is based on. So we'll do j equals 1, 2, 3. So we're not even really re-indexing, right? We're not even really re-indexing. We're using the same index as before. I'll call it j. And so what is our general term? So we already did it. -1 to the j plus 1 times why? What am I missing? This is only the nth. This is only this is only the derivative, right? This is in the Taylor series. What else do we need? X minus 3 j over
The first x is not x.
exactly. So the derivatives are what you get when you plug in. So we're plugging in 3 in for x, as we would do in this box right here. So this is 3 to the j, and this is j factorial. Okay, so now, before we do the ratio test, so this is what we're doing the ratio test on, but before we do that, can we simplify anything? Do you see anything that can simplify? I got j minus 1 factorial and j factorial. So I can get rid of the j minus 1 factorial and what's left on the bottom? Just j, right? Just j. So that'll be a lot nicer for the ratio test. You do x minus 3 to the j over 3 to the j. You could even make that all x minus 3 over 3 to the j if you want. And then this over j. Zero to 6. Okay, endpoints. Add 0. You get? You plug 0 in. Yeah, so you get the harmonic series, so it diverges. What about 6? Is that the alternating harmonic? Yep, so we got that. So you should get 0 to 6 is your interval. If you plug 0 in, you get the harmonic series. If you plug 6 in, you get the alternating harmonic series, which converges. So here's our interval. So this is the first time we've gotten an interval that wasn't all real numbers. And this makes sense because natural log of 2x, it's undefined at 0 and less than 0. So it would have to, can only possibly converge for x is greater than 0 because that's where natural log of 2x is defined. But then this is, on the right side, we're seeing it converges to x equals 6, but then not for x is greater than 6. So let's watch that happen. Any questions on the math? Were you able to do that? I kind of wrote it down as you were working, so is there any questions? Okay, let's see it here. All right, so here, what am I showing you now? What am I showing you? Yeah, so this is like the 0th degree, which is just the ln of 6, right? Just the ln of 6. And then first degree will be what? What will the first degree? What will it look like? Equation of the tangent line. It's the equation of the tangent line. Second degree, parabola. The red parabola, again, gets the first and second derivatives and the function value right at 3, approximates ln of 2x close to 3. Third degree, fourth degree, fifth degree, sixth degree, seventh, eighth. So notice it's going to converge from what? We said 0, not including, to 6 including. So what happens, do you see what's happening for x greater than 6 no matter how many terms I take? It just keeps flipping up and down. So here's the 20th degree. And you see the interval that you guys just calculated. 0, so this is going to converge for x greater than 0. And then it's going to converge at x equals 6, but as soon as you get past 6, those polynomials are going to either flip up to infinity or down to infinity. And so there's your interval of convergence, 0 to 6.